Electrical Machines Laboratory. Now we are going to see the separation of no-load losses in a single-phase transformer. So the aim of this experiment is to separate the eddy current loss and hysteresis loss from the iron loss of a single-phase transformer. So the apparatus required for this experiments were rheostat, wattmeter, ammeter, voltmeter and some connecting wires. So precautions to be done before starting the experiments were, so ensure whether the motor field rheostat is in minimum resistance position. Also the alternated field rheostat should be kept at maximum resistance position. So ensure these things before starting the experiment. So this is the circuit diagram. So this is the motor and this is the alternator which is being coupled to the motor. So the input to the alternator is from the motor. So here we are having the input supply which is 220 volt DC supply. It is being given to the motor through a starter. So here we are using 3-point starter. So the terminals were L, F and A. So here we are having a rheostat which is connected to the field. Next in the alternator side we are having a wattmeter, so which gives the iron loss reading. So at the end we are having a transformer. So the transformer which we are using, it is a step-up transformer. So in this way we have to connect. So now let's start the experiment. So this is the panel for conducting separation of no-load losses. So circuit connections were given as per the circuit diagram. So this is the input supply and this is the 3-point starter, and next the field winding is connected to the rheostat, and the armature terminal is connected to the A point of this motor, and this is the alternator side connection. So the alternator is being connected to the wattmeter, and this is the wattmeter which we have used, and this is the transformer which is used to conduct this experiment. So now let's turn on the supply. So before turning on the supply, ensure whether the motor rheostat is in minimum position. So it is as such, and similarly the alternator rheostat is in maximum position. So it has been ensured. Now turn on the supply. So gradually start on the starter. So by varying the motor field rheostat, brought the speed to its rated speed. So here the rated speed is 1500 RPM. The alternator field rheostat, rated voltage is being set in the primary of the transformer. By varying the field rheostat of the alternator, the primary voltage is applied to the transformer which is 200 volt. This is 2. Now, by varying the motor field rheostat, note down the readings of wattmeter and voltmeter for different frequency. So by varying the motor field rheostat, the frequency is being varied. So actually the frequency variation cannot be done directly. So by varying the motor field rheostat, the speed will change. So through speed we can calculate the different frequency
தொடாதீங்க மேம், தொடாதீங்க, ஸ்பார்க்.
So for different speed, note down the readings of wattmeter, ammeter and voltmeter. So this wattmeter reading will give the iron loss. So from this wattmeter reading, that is from iron loss, we have to calculate the hysteresis and eddy current loss by means of using the formula. So this is the tabulation. So here we have to note down the speed reading, voltage reading and wattmeter reading. So the frequency and iron loss, frequency as well as the hysteresis loss and the eddy current loss were calculated by means of using this formula. So this is the formula to calculate the frequency, and hysteresis loss we are having WH is equal to A into F in watts. Similarly, eddy current loss we are having this formula, and iron loss, this iron loss will be taken from the wattmeter reading which is being used in the experiment. So then plot a graph against frequency as well as and Wi divided by S. So with this characteristics you have to calculate the constants A and B. So in this way we have to conduct the separation of losses experiment from the single phase transformer without load condition. Thank you.